Hello everyone, I am Anikate Koul and today we'll be discussing the 13th problem from the CP-31 sheet by TLE Eliminators under the 1200 problems. I'll be moving to my CP-31 sheet and we can see that the 1200 problems has been checked. Now I can move down to find my 13th problem, virus. So let's begin. Now the problem statement is as follows. There are n houses numbered from 1 to n on a circle. For each house between 1 and n minus 1, house I and I plus 1 are neighbors. Additionally, house n and house 1 are also neighbors. Initially, m of these n houses are infected by deadly virus. Each morning, I think it is Cyrno. So Cyrno can choose a house which is uninfected and protect the house from being infected permanently. Now, every day the following things happen in order. Cyrno chooses an uninfected house and protects it permanently. All uninfected, unprotected houses which have at least one infected neighbor become infected. Cyrno wants to stop the virus from spreading, finding the number of houses that will be infected in the end if she optimally chooses the houses to protect. Note that every day Cyrno always chooses a house to protect before the virus spreads. Also, protected house will not be infected forever. Now for the input format and the constraints, the first line of each test file would contain a single integer t denoting the number of test cases which can go to 10 power 4. Then the first line of each test case would contain two positive integers n and m denoting the number of houses on that circle and the number of houses that are initially infected. Now n can range from 5 to 10 power 9 and m can range from 1 comma min of n comma 10 power 5. The second line of each test case consists of m distinct positive integers a1 till am, where each ai is between 1 and n. These are the indices of the houses that are initially infected. It is guaranteed that the sum of m overall test cases does not exceed 10 power 5. So now for each test case, you have to output a single integer on a separate line denoting the number of infected houses in the end. Right. As we have read the problem statement, we can move on to understand it. So for every test case, it is given that we have three things, n, m, and a. So n and m are integers and a is an array. Now let's discuss what does n, m, and a actually mean. N is the total number of houses. M is the number of houses which are initially infected. M is the number of houses that are initially infected before the start of our process, and array A denotes the indices of all these houses which are initially infected. Right. So this is what our input means. Now what we are asked is that, let's say we are at the beginning of day 0. Right. On the beginning of day 0, the main player here, Cyrno, she has the option to protect some house. Right. So every day she can protect exactly one house. So what does it mean to protect a house? You can select a house and then that house will not be infected ever. Right. So it gets permanent immunity. Now this can be repeated every day, and after, let's say, day 0, Cyrno picks an house, let's say I, with an index I. That house is permanently protected from an infection, and then all the houses, let's say J, where J goes from 1 to n, where the J house has at least one neighbor who is infected. Also remember, all these houses are on a circle, so 1 and n are also neighbors. Any house J which has at least one neighbor which is already infected will get infected now, right? After Serno chooses an house to be protected. And this process repeats till all the houses are either infected or protected, right? So on day one also, we'll repeat the same, Serno will repeat the same thing. Choose some uh, house I1 or I dash, let's say, protected permanently, and then again for all j from 1 to n which are not protected already and which have at least one neighbor who is infected will get infected. As I said, this will continue until our houses are either protected or infected, and at the end we have to output the minimum number of houses that were infected if Serno chooses the houses optimally, right? So minimum number of infected houses. Now let's see a sample case which will help us understand the problem better. Now let's take this first one, for example. Let's paste this here and remove anything that is not required. Also, let's increase the font size so it is better visible. Now this is n and this is m, and this is our array A. So according to our input, we have 10 houses. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. We have all these 10 houses. Actually, these houses are on a circle. I'm drawing on a straight line, but try to visualize that 1 and 10 are also neighbors. So they are adjacent to each other. So they're arranged in that in such a manner. But it is also given that the houses 3, 6, and 8 are already infected before the start of any operation. So now Serno has to start her job and start protecting houses. So let's denote all the protected houses with the color green, right? So on day 0, what Serno can do is protect the house 2, right? This house is protected. Now again, all the infected houses will be denoted with the color yellow. So after Serno has protected the house number 2, the houses 4, 5, 7, and 9 will get infected. 4 because it has both neighbors who are already infected. Oh, sorry. 5 was not initially infected. So let me step back a bit. Yes, so this was the initial one. So it will be better if I explain it while drawing. So 3 was initially infected, so 4 gets infected, right? 6 was initially infected, so 5 gets infected. 6 and 8 both are initially infected, so 7 also gets infected. And 8 is infected, so 9 also gets infected, right? So this is the situation at the end of day 0, right? Serno has predicted one house and these all houses have got infected. Now what Serno can do at the start of day 1, she can protect the house number 10, right? Now as she has protected the house number 10, you can see only house 1 is left, but house 1 has two neighbors, 2 and 10, both of which are protected. So we can say that in no case the house number 1 can get infected, because both of his neighbors can never get infected, right? Because both of them are protected, so one can also never get infected. So on day 2 nothing will happen, or day 1 actually, because on day 0 2 was protected, on day 1 10 was protected, and now nothing will happen on day 1, so day 1 closes. And now at the beginning of day 2 we protect 1 again, and now, as I said earlier, that we have reached the case where each house is either protected or infected, so the operation stops. So now we can see here that we have 1, 2, 3, 4, 5, 6, 7. 7 infected houses and 3 protected houses. So as we have to output this value, 7, which is the number of houses infected, we'll output 7, and we can check for ourselves that in no other case we can protect more than 3 houses, or in no other case less than 7 houses can be infected. So that can be confirmed if we check here that the answer is 7, right? Now let's discuss the expected time complexity. So one interesting thing about this question is that n can go up till 10 power 9 for every test case, right? And also it does not have any bound overall test cases. M on the other hand can be from 1 till minimum of 10 power 5 comma n, right? And M has a bound, so sum of n overall test cases is less than equal to 10 power 5, I believe. Let's check that. Yes, it is 10 power 5. So what we'll try to do is formulate an algorithm which is dependent on M and not N, right? Because N per test case can go to 10 power 9 and it does not have any bound overall test cases. So it is very difficult to come up with an algorithm which is dependent on N, because it doesn't really have a bound. M does, so we'll try to formulate an algorithm based on M. So let's say we formulate an algorithm which takes O of M time. So that would take 10 power 5 operations, right? And if you have a doubt that why I'm not writing it as O of T into M, because M already has a bound overall test cases. So instead of writing O of T into M, I can simply write it as O of M, right? So O of M time complexity will yield 10 power 5 operations. O of M log to the base 2 of M would go 10 power 5 into 20, because approximately log base of 10 power 5 is 20. This would be 2 into 10 power 6, and O of M square would go up till 10 power 10. But we also know that on Codeforces in 1 second we can run approximately 10 power 8 elementary operations, right? That means O of M runs fine, so does O of M log n, but O of M square does not work, right? Because it exceeds the limit of 10 power 8. So we want some algorithm which runs in the vicinity of O of M or O of M log m, right? So as now we have discussed the expected time complexity, we can move on to discussing the solution. So for the first part of our solution, let's take a case where I tell you that I have two houses, let's say house 1 and house 2, right? Now I'll consider only the houses H1 and H2 and all the houses between them, right? So for now, let's consider only this case. Let's forget that there can be houses on the left side and on the right side and it is circular. Let's forget everything. Let's say H1 and H2 are two houses which are initially infected. I've given you that. All the houses between it are not infected as of now, right? And I ask you the same question, that by the end of the operations, that is when either all the houses are infected or protected, I want the minimum number of infected houses, like in the problem statement, right? And I also give you the same terms, that at the beginning of every day you can protect exactly one house, and after that houses start to get infected, giving the same condition that if a house has at least one neighbor is already infected, then it gets infected, right? So all the conditions are same, but for now I am not giving you that multiple houses are infected and you have a circular uh, neighborhood and everything. It's just that you have two houses, H1 and H2, and you have some houses between them. Now you have to answer the same question given the same conditions. How would you start protecting houses is the main thing that I want to know, right? So what would you do? Would you protect houses like the neighboring house to H1, and then this house would get infected, right? And then you would protect this house, and then this house would be infected, and then you would protect this house and so on. Is this optimal? Or would you do something like you'll protect the middle house and these two houses get infected, and then you protect the house to the left or right or middle, and then again these two houses get infected? There are multiple ways, right? I am listing out only a few of them, but what do you think would be the most optimal way in order to infect the minimum houses possible, or in other words, protect the maximum houses possible? How could I do that? Try to think about it. Wouldn't it be optimal that firstly I protect any neighboring houses to the initially infected one? So either this one or this one, any one of them, right? Let's say protect the left one, right? So what would happen now is this houses get infected because I'm only considering the houses H1 and H2 and everything between them. I'm not uh, worried about all the houses to the left of H1 or to the right of H2, right? So for now, only this house gets infected. Now what I can do is protect this house, right? Left of the house that just got infected. Now you can see that all these houses here can never get infected because they are surrounded by protected houses, right? So they will never get infected. So you can see that all the methods that you try out, this is the most optimal way to protect the maximum number of houses possible. That you seal off the surroundings and all the houses in the middle automatically get protected, right? So this answers a very important question, that is, given a range, between two initially infected houses, what is the most optimal way to protect the houses in the middle? Now we know the most optimal way to protect houses in the middle is try to protect the surrounding houses first, so that you can create a barrier of some sort and all the houses in the middle get protected automatically. Now, as you have answered this question, we have to answer another one, right? The other question is that in the original problem statement, we are not just given H1 and H2 and we have to protect the houses in middle. In the original problem, there is a circular neighborhood where 1 and n are neighbors, and we have 2, 3, 4, so on till n, right? So this kind of neighborhood, and some of these houses are initially infected. Let's say these houses are initially infected, and now we have to protect the maximum number of houses. This is the original problem, right? So how do we incorporate this logic, this above logic, into the original problem statement, right? So there is one more important problem statement that we need to keep in mind, which will help us solve this original problem. That is, it is always optimal to first protect the largest range. So let's say houses H1, H2, H3, H4 are infected, and these H1, H2, H3, H4 are given by the array A. So you can take A1, A2, A3, A4 till AM. These are the houses which are initially infected, right? Let's say I sort all these values. So for every pair, every adjacent pair, I have that AI is less than AI plus 1. right? I sort them so that I always get neighboring houses together. So now let's say it converted to some array B. So B1, B2, B3, so on till Bm. Now it satisfies the condition that Bi is less than Bi plus 1 for every I, right? Now let's see. The gaps between these already infected houses are B2 minus B1, B3 minus B2, so on till Bm minus Bm minus 1. And there is another gap, very important, because we know that this is circular, right? So between the first and the last infected house, we'll also have a gap. How do I know the gap there? That would be n minus bm plus b1 minus 1, right? Because the gap between n and the last infected house and the gap between 1 and the first infected house, right? One more important thing to remember, b1, b2 are both infected. So the number of uninfected houses initially between them would be b2 minus b1 minus 1, right? Because let's say 1 and 3 are both infected, so the number of uninfected house between them is only 2, that is equal to 1 house, right? So that would be 3 minus 1 minus 1. So remember here, everywhere I have to put a minus 1, except this place. This is already covered, I don't need to do anything. Now let's see. Why do I say that I will always choose the largest range first? So the largest of all of them would be chosen first, because my logic is to protect the surrounding houses. So let's say this house and this house was infected. I protect these two houses, and then the range between them is protected, right? So anyway, for any range of any size, I will only take 2 days to protect the entire range, right? Whatever is available at that point of time. So I will take only 2 days, irrespective of the length of the range. So isn't it optimal that I first protect the largest range? Because anyway, I need only 2 days for it. So if I protect the largest range first, I would be able to greedily choose the maximum possible range, which can in turn protect the maximum number of houses, right? So I hope this logic is clear. I can repeat it again, that if I have multiple options, let's say one range has 6 unprotected houses, another has 3, another one has 5, another one has 2, I will always protect the range with 6 uninfected houses, because anyway, for every range, I will take 2 days, right? But if I spend my 2 days here, I would be able to protect 6 houses. Instead of, if I used my 2 days here, I would be able to protect only 2 houses. So that is my main observation, to say that always protect the largest range first. So my algorithm is pretty simple. It comes out to be that first, sort all the houses that are initially infected, that is the array A, in increasing order, right? So that you have all the neighboring, all the consecutive houses together. Or you could say that A of I should be less than A of I plus 1 for every house. This is the condition that we need to achieve first, so that we can get the ranges, right? So let's say I sort it. After sorting, I receive the array B, right? It has the same elements but in different order. So now I calculate the ranges B2 minus B1 minus 1, B3 minus B2 minus 1, and everything, right? So on, and the last range would be B, sorry, let's erase that. The last range would be N minus Bm and plus B1 minus 1. I hope I written that earlier as well, right? So these are the ranges or the uninfected houses between every range. then I would greedily choose the largest range every time and protect it by taking 2 days, as I mentioned above, right? And what I would be essentially doing is trying to calculate the maximum number of houses that we can protect, right? So let's say I store that in the value val. So val tells me at the end the maximum number of houses that I was able to protect. But then in the question, I want to answer the minimum number of infected houses. Both are the same, but we have to just change the output value. Both are, I mean, they mean the same thing, but they have different numerical values. But the numerical values have a relation that if I say val is the maximum number of houses that I could protect, then n minus val is the minimum number of houses that were infected, right? So I just print n minus val. So this is my whole algorithm. If I come to the time complexity of this algorithm, then initially I have to sort the array A. As array is of size m, I take m log m time to sort the array A, and then I take another O of m time, sorry, to calculate all the gaps, and then for each gap it is O of 1 to calculate the number of protected houses, right? So overall the time complexity comes out to be O of m log m, and as we saw earlier, this works pretty well. Now let's see the implementation. So I take the input for the number of test cases, then for each test case I take in input for n and m, then I take input for the m houses, sort those houses as I said earlier, then calculate the gaps between these houses. That is, after sorting them, as I said, b of 2 minus b of 1 minus 1 similarly. So that's what I do here. So taking input takes O of m time, sorting them takes O of m log m time. Again, this loop takes O of m time, and I have, as I said, pushed the gap between the first and the last infected houses, right? It is the same thing, just the terms are rearranged so that all the positive terms come to one side and negative terms go to the other side. Again, sorting this vector would take m log m time because I want to greedily choose. So num saved stores the maximum number of houses that I was able to save. Num days tell me which day I am on. So initially I'm on the 0th day. So how do I calculate that what are the number of houses that I was able to save? So obviously, if a range has unprotected houses on both sides. So if I go back here, I can see that any range has two unprotected houses, right? This is unprotected, or I should say infected actually. These are infected, both of them are infected, right? So every day, if I don't do anything, this neighboring house will get infected and this neighboring house will get infected, right? So if I don't do anything on that range, every day two more houses will get infected, right? Till no house is left. So essentially, if I leave this range alone for x days, let's say x days, then if initially there were y number of uninfected houses, initially if there are y number of uninfected houses, then after x days I would have y minus 2x. So maximum of 0 comma y minus 2x uninfected houses after x number of days, right? Because every day two houses are getting infected. That's what I did here to calculate the current number of uninfected houses that is stored in the value current gap. I calculate gap, that is initial number of infected houses, minus num days into 2, that is number of days that have passed into 2. Now if cur gap is greater than 0, that means there are positive number of uninfected houses still left, right? So that means I can save at least one. So I save that one house, that is the left extremity of the current gap, right? Now what happens is that one extremity has been saved, the other extremity gets infected, right? Because I have taken 1 day for it, 1 day to protect one house, right? So my current gap again reduces by 2 because one has been saved and one has been infected. Now, if again the new gap left after the current day has passed has positive number of uninfected houses, I'm saying uninfected, not unprotected, right? Uninfected houses, then num saved plus equals to current gap. What it does is it says that now I will protect the other extremity as well. So all the elements currently left will get protected. So this means protecting the right extremity and all the elements in the range. That's why I add that value. And then num days plus equals to 2 represents that now 2 days have passed. Because as I said, I require 2 days to protect a given range. Now I keep doing it greedily because I have sorted in reverse order and I simply output n minus num saved because that is the value we require, minimum number of infected houses. So overall, if we see the total time complexity comes out to be O of m log m, and the total space complexity comes out to be O of m, because we are storing multiple vectors even though of size m, but still it would be some constant multiple of m which is still O of m because we are writing the asymptotic complexity, right? So I hope you like the problem, and for the ending remarks I would say this problem was quite interesting because it involved a bit of mathematical reasoning and greedy logic as well. So at the end it was a combination of multiple topics which made it like quite fascinating to solve. So I hope you like the solution. Thank you.